Verifying the date format of an input string, part 4. In part 2, we validated the data format. In part 3, we validated the data type, namely, was it integer data? Now, in part 4, this part of the video series, we need to determine whether the information contained in the proposed date string corresponds to an actual date. At this point, we have written the code to verify whether the input data is in the correct form, format, and type. We now need to determine how to make sure that the information contained in the date string represents an actual valid date. For example, 01/29/2001 is valid, where 02/29/2001 is not valid. February 29th is not a valid date because 2001 is not a leap year. So it seems that we can do this in a very straightforward manner. We know how many days January has. It has maximum 31 days. So if the month is January, we know that the date entered on the date string would have to be between 1 and 31. If the month was April, we know the day of the date string be between 1 and 30, etc. Now, February, we have to check two things. If it's a leap year, we have to allow a maximum date of 29, and if it's not a leap year, we have to allow a maximum date of 28. So let's see how we can write this code. Let's write our function to do the last bit of validation, namely to determine if the information is actually correct. Let's call this function isValidDate, and let's operate on the same date string. Let's call it the same thing, dstring. Let's use what we did before from the slices. So we're going to have a year, which is the integer conversion of the appropriate slice, month and day respectively. Let's call our function, once we have this year being an integer, let's call our function isLeapYear and assign that to the variable leap year. Okay, so now let's first go through our logic. Let's take care of the simplest thing, the year. Our specifications said the year needed to be between 1800 and 2030 inclusive. So, or the year is greater than 2030. This would represent non-compliance with the specifications. We'll return a false to the calling program. Now, it's important to note that for this next bit, let's first, what would be next? Let's check the months. Well, the month first would have to be between 1 and 12 inclusive. And if not, then you have an error in the month data, so we'll return a false. So this would represent an error in the month specification. All right, so now if we're in this block, we know that the months are correct between 1 and 12, so now we go to verifying the days to see if the days are correct. And now we do this per month. If the month is January, which has a number of 1, and January we know has between 1 and 31 days, then we're going to return true. We're going to be done with our analysis because think about it. At this point in the logic, the year would be correct, otherwise we wouldn't have gotten into this statement. The month is correct because we're in this block. And if the month were January and this condition holds, then that's the last piece of information that would have needed to be verified, which was the day. That would be correct. So we're returning true. Now let's copy this here. Now we're going to build an LF ladder. So if the month, let's do all the months with 31 days first. So the next one is March. Let's line this up. It reads a lot better. Let's put some comments here so we can keep track of what we're doing. This would be January. This would be March. So what's the next month with 31 days? It would be May. Now let's copy this whole line. See, this way I don't have to change this part of the code. I'm doing all the months with 31 days first. So this would be May. July is the next month, which would be 7. Change the comment. August would be the next month with 31 days. This would be August. The next month with 31 days is October, which is 10. And you can see now we're out of alignment in terms of everything looking very nice and neat. So let's skip these over. Now look, everything's lining up beautifully, very easy to read. And the last month would be 12 December. All right, so now let's check those months with 30 days. Okay, the first one would be April. Let's change this to 30. What's the next month after April with 30 days? June. Let's actually copy this line because it has the 30. So it has the 30 in it rather than the 31. We only need to change one data item and the comment, of course. And what's the next month after June? Should be September. Okay, we're almost there. One more month. Could be November if I'm thinking correctly. And as a month number of 11. Change our comment. Now the way I'm doing this logic, well, let's leave February to last because it's the most tricky. All right, so if the month is February, and we have two cases for February, we know it's possible to be in a leap year or not in a leap year. All right, so if, let's put here February, change my comment. This is February leap year, we'll call it leap. All right, let's see what happens. If the month is February and it's a leap year, and the days are between 1 and not 30, but 29, then this would be correct. We'll return a true. And what's the opposite of leap year? Not a leap year. And then if you're not a leap year, the highest you can go would be 28. Let's skip this over so it reads a little better. And we'll call this February not a leap year. Let's scroll over to see how the comment reads. Okay, good commenting. And then, now the first thing we have to note is that this is exhaustive. So notice we went through all the months from January to December, including February, which took 2 statements to determine. So remember, the if-elif ladder will terminate where the first block is true. So what happens if none of these are true? Well, then you have bad data because we've exhaustively captured all the cases which would be correct. So if, in this case, we need to return a false. And again, as I've mentioned, we're not doing really any error reporting to say where the defect occurred. It could have been you had 29 days in a February that was not a leap year. It could have been the case that you had 31 days in April. We don't know. Could have had 45 days in December, which would have obviously be, again, bad data. We're not caring to distinguish that at this point. So let's test it. So let's test this function. Let's use our typical test string. Let's get some data from the user. Now, this will be another great example of short circuit evaluation. We will check our first condition. Rather than nesting these, as we can call them all at once. Well, sequentially. In one single line, let's say, executed sequentially. If it wasn't being executed sequentially, we wouldn't have the short circuit evaluation. All right, so we're going to check all 3. Now, this is the beautiful thing. If either of these 2 conditions is false, it will not make the call to isValidate. That's short circuit evaluation. So you see, so we're protected here. This is a dangerous call to the int function if the data represented here was not decimal or numeric data. It would cause a runtime error. But if that's the case, we already tested that here. And if that were the case, this would return false. And by short circuit evaluation, this call would never have been made. So that's a great example using short circuit evaluation. All right, let's do our else block. And again, as we did last time, let's say you did not enter the correct validate string. Let's run it and see what we get. I have a typo, typed it as a capital A in the function definition, which obviously I didn't want, but this is what I thought. So now let's rerun again. So let's do December 25th. And you have entered a validate string. Let's run something that's wrong. How about December 35th? You did not enter a validate string. Again, this error reporting is not robust. It probably should have told us something that it was the days that caused the error, not the month or whatever. But let's run it again. You could have the 13th month, the 4th day of the month. You did not enter a validation. Let's check the leap year. February 29th of 2000 was a leap year. Does it get it? Yes. Let's check February 29th of 2001 was not a leap year. Lastly, let's check that short circuit evaluation. Let's say we have a month of 01, which would represent January. Let's not put integer data in for the day. We did not trigger a runtime error. It just says did not enter a valid string, which would be correct. Excellent. So now we have completed this phase of the problem, which was, and up to this point, probably for the introductory or the beginning programmer, the most challenging bit to work through that. And again, there are other ways to write this function. We could have been a little more clever, and we could have condensed this. You see there's a lot of similarity in this structure. Perhaps we could have done an OR statement for all these cases. We might have been clever and tried to do some using some string functions and say if the month string was in a string with these numbers. But anyway, we could have done this in many other ways. In this video series, I have not introduced lists yet, so we will not be using those types of constructs to make this determination. So I simply coded this in a very flat way to illustrate the logic involved. So now let's turn our attention to the next phase of our programming problem. I'm Tim Sever. Thank you for joining me for this video installment. Like the video, comment below if you have any questions, and don't forget to subscribe for updates regarding videos on this channel.